In this video lecture, we are going to see about clipper and clamper circuit using operational amplifier. Basically, what is a clipper circuit? Clipper circuit are called as a wave shaping circuit. In this slide, I design a clipper circuit using diode and resistor. This type of clipper circuit is called as a passive clipper circuit. When we design a clipper circuit using diode and resistor, it won't behave as a perfect clipper circuit. In this diagram, I apply my input as sinusoidal wave. At the output, you can see that the more than half portion of the positive cycle is clipped. It is called as a positive clipper circuit. But here, the entire positive cycle is not clipped. We all know that what is the reason for that. The forward voltage of the diode is 0.7 in case of silicon and 0.3 in case of germanium. So when the input of the sine wave is greater than 0.7, then only this circuit will operate. In order to get the precise output, we design a clipper circuit using operational amplifier. Before see the clipper circuit using operational amplifier, first we see a small introduction about operational amplifier. What is amplifier? The amplifier is used to amplify the given input signal. As the name suggests, operational amplifier is used to perform operations like addition, subtraction, multiplication and division. Some of the applications of operational amplifier are active filters, oscillators, analog to digital converters and digital to analog converters. The characteristics of ideal operational amplifier are listed in this slide. First, it has infinite input resistance and zero output resistance. Bandwidth of the ideal operational amplifier is infinite. Therefore, it can amplify all the signal from the bandwidth 0 to infinite. Next one is open loop gain of the operational amplifier is infinite. Infinite slew rate and common mode rejection ratio. Slew rate is used to determine how fast it will reach the output. Common mode rejection ratio is defined as ratio of differential gain to the common mode gain. We are going to see about active clipper circuit. What is active clipper circuit? When we design a clipper circuit using diode and operational amplifier, it is called as an active clipper circuit. In the diagram, I design my active clipper circuit using operational amplifier and diode. When operational amplifier and diode are connected together, then the diode is called as a super diode. Here I apply my input to the positive side and I am connecting the negative feedback. I am getting my output through the resistance RL, V out. Here I apply my reference voltage as positive reference voltage. You can also take your reference voltage as negative reference voltage. In the previous slide, we see the construction of the active clipper circuit. In this slide, we are going to see the working of the active clipper circuit. This is the active clipper circuit and I am giving the input as sinusoidal waveform. So here I am taking the positive half cycle of the given input and this is my circuit. At node A, the difference between these two voltages will appear. I am taking the maximum voltage Vm as 3 volt and the reference voltage as 1 volt. When I apply the input as 0 and the reference voltage as 1, the difference between these two voltages will be minus 1 volt. When the difference between these two voltages is negative, the diode will on and the output waveform will follow the input pattern. At 0, it will follow the input pattern. When I apply the input as 1 volt, now I am applying the input as 1 volt, the difference between these two voltages will be 0 volt. That time also the diode will on and the output waveform will follow the input pattern. This is the output waveform. When I apply the input as 2 volt, the difference between these two voltages will be 1 volt. At that time the diode will not on, it will off. When I apply the input voltage as 3 volt, that time also diode will not on, it will be off. Here I take my negative half cycle, my maximum voltage is minus 3 volt, my reference voltage is 1 volt, and this is the circuit. The difference between the non-inverting and the inverting terminal will appear at the node A. The difference between non-inverting and the inverting terminal is negative. So the diode will on and my output waveform will follow the input pattern. So here my output waveform will follow the input pattern. So it is a positive clipper circuit. In the previous slide, we see the construction and working of the active clipper circuit. In this slide, I am going to conclude the active clipper circuit. Active clipper circuit is used to clip either positive half cycle or negative half cycle. But what is the major difference between the active clipper circuit and the passive clipper circuit is the passive clipper circuit only clip if the input waveform is above 0.7 volt in case of silicon and 0.3 volt in case of germanium. But the active clipper circuit will clip the input waveform even if it is 60 microvolt. This is a major difference between the active clipper circuit and the passive clipper circuit. We can clip the waveform as per our wish just by adjusting the reference voltage in the active clipper circuit. This will be the major advantage in the active clipper circuit. Next, we are going to see about the clamper circuit. A clamper is an electronic circuit that changes the DC level of a signal to the desired level without changing the shape of the applied signal. The clamper circuit is divided into two types. One is positive clamper circuit, another one is negative clamper circuit. The clamper circuit designed with the diode and resistor is called passive clamper circuit. When we design a clamper circuit using diode and resistor, the ideal waveform will look like this. But due to the voltage drop across the diode, the waveform will look like this. In order to overcome this, to get the precise output, we designed a clamper circuit using operational amplifier. This is the clamper circuit using operational amplifier. When we connect the diode to the operational amplifier, the diode is called as a super diode. Here I apply my input to the inverting terminal and I apply my reference voltage to the non-inverting terminal. I am getting the output as Vout. When we didn't apply any input to the circuit, the output will equal to the V reference. Here I apply the sinusoidal input. I consider the negative half cycle. When I consider the negative half cycle, the diode will be forward biased and the capacitor will get charged. When the capacitor gets charged, the Vc of the capacitor is equal to Vm plus Vr. So now I apply the positive half cycle. When I apply the positive half cycle to the clipper circuit, it will be a open switch. So it will not conduct. The V out of the circuit is equal to V in plus Vm plus V reference. As we already know that V out from the previous slide that V out is equal to V in plus Vm plus Vr, where Vn is the input voltage and Vm be the maximum voltage and Vr is reference voltage. Here I take Vm, maximum voltage as 3 volt, reference voltage as 1 volt. So when I apply the input voltage 1 volt, the V out will be 4 volt. When I apply input voltage 2 volt, the V out will be 6 volt. When I apply the input voltage 3 volt, the V out will be 9 volt. In the next slide, we will see the output waveform for the positive half cycle. This is the output waveform when we apply the positive half cycle to this. When we apply the negative half cycle to this clipper circuit, first my Vin is equal to minus 1 volt. When my Vin is equal to minus 1 volt, the V out is equal to positive 3 volt. When my V input is equal to minus 2 volt, my V output is equal to positive 2 volt. When my V input is equal to minus 3 volt, my V output is equal to positive 1 volt. In the next slide, we will see the output of the negative clamper circuit. This is the combined output waveform for both positive half cycle and negative half cycle. For positive half cycle, at the output waveform, we have the maximum voltage of plus 9 volt and the negative half cycle, we have the least value of voltage as plus 1 volt. Here, I conclude the clamper circuit by saying that clamper circuit is used to change the DC level of the given input signal to the desired level, and clipper circuit is used to clip the either positive half cycle or negative half cycle. This is all for this presentation, and I conclude this presentation here. Thank you.